everyone, a very warm welcome for you on this event on connected and automated driving, featuring industry, technology and market updates. This webinar will take place on 2 days with a unique program each day. My name is Vincent Troes and together with my colleague Thomas Jaeger, we'll be your hosts for today and for tomorrow. Protecting our health in times where we face many challenges around us has become a central topic in our lives. Technology can help to enhance this safety at home, at work and on the roads. And this is what DEKRA stands for. In this event we will be focusing on making mobility safer by using technologies and concepts in connected and automated driving. Developments are progressing very fast and we are delighted to share valuable information and updates with you. We are very happy to have been able to mobilize quite a number of knowledgeable DEKRA partners from not only the telecom but also the automotive industry to talk about their areas of expertise.
Thank you very much, Vincent. So we intend to give you a good overview of the entire ecosystem around connected and automated driving, as well as we will have contributions from various players out of the value chain, such as network vendors, network operators, association, device vendors and chipset makers. In this way, we can provide you multiple viewpoints on connected and automated driving. We have segmented the presentation into various blocks featuring 3 to 4 speakers each block. At the end of every block, we will have a panel session with most speakers where we will be able to answer any questions. For this special webinar, we are also very happy to get support from one of our important global partners, Telefónica. Before we continue with the first block of speeches, please listen to the welcome message from Mr. José Antonio Florido. José Antonio is managing the digital transformation strategy of corporate business and public administrations in the south of Spain for Telefónica. He is an engineer in telecommunications, MBA in marketing and sales, and PhD candidate in telematics.
We in Telefónica are true believers in using technology to improve the life of the people. And that's why we are putting a lot of effort, time and budget in guaranteeing that we are providing the best tools, technology, education and places where people can innovate. Just to mention some examples here in Malaga, Telefónica has signed a collaboration line of work with the University of Malaga focused on 5G, that together with the best fiber optic network in Europe and our edge computing nodes in Seville and in the very short term also in Malaga, is allowing us to deploy very innovative use cases. If we talk about innovation, we need to mention that also here in Malaga we have opened Telefónica's R&D Cybersecurity Center, where we are developing top-of-the-line cybersecurity solutions. We also have La Farola, an acceleration center for startups, and coming soon, 42 School, an academy that we are opening together with Malaga City Council, and where we will teach hard and soft skills using gamification. In this academy, you will be able to choose what to study and at what pace. Before finishing, it's also important to talk about one of the projects we are most proud of. We are deploying this project together with our strategic partner DEKRA, also here in Malaga, and it's the 5G Europe's most modern test center for autonomous driving. We are talking about a 50,000 square meter outdoor test field and a test laboratory where companies are already testing modern 5G solutions and vehicle to everything technologies. Remember, technology, education, innovation, and of course, people are key pillars of evolution. So those need to be a priority for everyone. Thank you very much for your time, and I hope you enjoy this very interesting session.
Thanks a lot, José Antonio, for that message. Now it is time to get started with our first speakers block on day 1, addressing the subject of technology updates. Our first speaker will be Dr. Ralf Weber from Qualcomm, Technical Director, Standards and Industry Associations. Ralf will provide an overview about the latest V2X technology updates.
Dr. Ralf Weber is currently working as Technical Director of the Qualcomm Standards and Industry Organizations Department, especially on 5G and vehicle-to-everything communication. He has a special topic and a special focus on standardization, testing and certification of communication systems for automotive applications. Ralf has more than 30 years professional experience in mobile communications and has held several engineering and management positions at Qualcomm. He also is Qualcomm's lead representative in different organizations, as well as part of his role is to support regulatory initiatives on EU and UN level. In addition, he is also acting as technical advisor for different R&D and deployment activities on 5G, V2X and eCall. The topics of his speech: an overview about the latest technology and the V2X update.
Yeah, hello everyone. First of all, thanks a lot, DEKRA, for the kind invitation and giving me the opportunity to present a little overview of what connectivity can do or communication technology can do in order to support connected and automated driving. So let me pull up my presentation. Okay, the title of my talk is Connected and Automated Driving with 5G. Before I start, let me get us a bit into the mood, providing a little video from our product team. Please have a look.
When breakthrough technologies converge, connecting people, devices, and spaces, the impossible becomes possible. Infrastructure can work smarter. Transportation can become safer. Education can be more accessible. And new tools can enrich our lives. Manufacturing can be more efficient. Healthcare can be provided virtually anywhere. And our modern landscapes can be upgraded by the unified connectivity fabric of 5G with ultra-low latency and high reliability. Using neural processing, cognitive intelligence, and chip-to-cloud security, Qualcomm is helping digitally transform spaces big and small, far and wide, to enrich the lives of people around the world in smart cities and smart connected spaces.
So, yeah, what is 5G? 5G is not another Corona rule, as some may wonder. It's just the 5th generation of mobile communication, which some denote as the largest technology platform in human history. Of course, one can debate about this, but basically it all started back in the 80s with the first G, which was based on analog voice. It became 2G with digital voice, and then when mobile data was added in 3G, and we made it even broadband mobile data in 4G. And now 5G is the latest version, and you see here almost every 10 years we saw a new generation. And we expect, of course, another generation in about 10 years to come as well. So what differentiates 5G from the previous generation? So basically it allows now a relatively good integration of not only communication between individuals, but communication between things. And it does not only provide kind of a best effort service, but also is supposed to provide quality of service mechanisms that are dedicated for certain applications, for certain industries. And yeah, this slide shows a non-exhaustive list of different industry sectors where 5G will play a role in the future, and it ranges from manufacturing through energy distribution, logistics, transportation, of course, but goes also into healthcare and even agriculture. And all of that is supposed to be supported by connectivity, and the basic mechanism or the basic idea here is to base everything on the same technology, base technology, but then have different configurations, options in the technology in order to support then the needs of the different sectors. This creates, of course, a lot of opportunities, but also some challenges. And the opportunities are that we can hopefully achieve more efficient interactions within the sectors, but also between the sectors, because communication allows also to track certain devices during the manufacturing, during the delivery, and up to the final use by the end customer. Now, the challenges that we see are also multifold, and on one hand, for the telecom industry, it means that we need to look now into different sectors. We need to understand how they work, what the processes are, what the mechanisms are, what the needs are. This is one challenge. The other challenge for the different sectors is that they are now in a situation where they can make use of this technology, but that could also mean that they may need to change the way they work, the way they interact also with others. And even the interaction between sectors now becomes an important aspect. And also here, communication can, of course, help. When we look at the automotive industry and maybe in general on the transport industry, then not sure who of you has had the chance to visit IAA Congress this year in September in Munich, where a lot of new car models were presented that had partially huge displays, showed a lot of information, provided insight into the way how the car of the future may look. And for us, this future is not so far away, actually. But on the other hand, we see a transformation, of course, in the car itself. So we see a lot of connectivity. We see that the cars become increasingly autonomous, increasingly economic, and should also provide increasingly safer and comfortable driving experience. So, and one tool or one way to achieve that is often regarded as the assisted driver systems or autonomous driving. And for that, the car itself already today contains a lot of sensors that can help here. So beside positioning devices, we have certain sensors that detect certain objects. And the basic idea here is to allow the car to get a certain awareness of what's happening around it. So which kind of objects are there? Are there other road users? Are there any collisions potentially? And just to predict also the behavior of the different road users. But these sensors is not everything. So we think the communication can bring the autonomy to another level, simply because it will allow a way to interact also, meaning to negotiate certain behavior and to predict the movement of objects and cars in the surroundings where we are. And for this, connectivity, of course, plays a certain role, but it is not the only tool that can be used, of course. We still have, of course, sensors and everything. Nevertheless, the main goals that we see are, of course, lower emissions, safer roads, and higher comfort. 3GPP, the standardization organization for the telecom industry or for mobile communication, said, okay, why don't we try to create a way to communicate directly with road users? So communication between vehicles and the infrastructure like traffic signals or signal signs. Pedestrians, bicyclists, so we call them vulnerable road users, on top of the already existing network communication. And this communication, of course, should use a dedicated spectrum. We targeted for this the 5.9 gigahertz band for intelligent transport systems that exist today, so that everyone can use that technology there. The main advantage of this, what we call side-link communication or direct communication, is that it does not need a network. It can communicate directly in an ad hoc manner. So that also makes it independent of the network coverage from certain network operators, which is, of course, very important, especially when you are driving in areas where there is no network coverage. Okay, what are the typical use cases? I have another nice video. Please have a look.
The rollout of 5G will deliver ultra-low delay and ultra-high reliability, enabling a brand new set of use cases. With the help of multiple sensors and technologies, cellular vehicle to everything-enabled vehicles communicate quickly and reliably with other cars, pedestrians, traffic lights, and everything in between, enabling non-line-of-sight awareness and the ability to detect intent, providing greater situational awareness for safer, faster travel. Currently, without CV2X, if a car pulls out in front of you unexpectedly, you would likely hit it or swerve to avoid it, possibly causing an accident in oncoming traffic. With CV2X, you would receive a warning that a car on your right is starting up, giving you enough time to hit the brakes and avoid an accident. Without CV2X, it is impossible to see around objects such as buildings, trees, or parked cars. You can't see if someone is crossing the road or if any other obstructions lie ahead, and often accidents can't be avoided. With CV2X, a camera embedded in the traffic light detects a pedestrian in the crosswalk and communicates quickly and reliably with everything around it, including your vehicle, giving you enough time to slow down, preventing an accident. With CV2X, surrounding vehicles and smart infrastructure consider each vehicle's velocity and distance from the intersection to decide right-of-way. The CV2X negotiation determines it's safe, and our car continues through the intersection without slowing down. Cars without CV2X must stop at every stop sign or red light. Non-stop travel gets us where we're going sooner and saves money. In our simulations, autonomous CV2X trips in an urban environment had better than 20% savings of fuel and travel time. Citywide, this will add up to less traffic congestion, less pollution, and fewer accidents.
I will come back to the fuel saving and energy aspect later on. Before that, let me just quickly summarize. So we think that the communication aspects allow a different way of interaction between road users, and this on top of already existing sensors like radar, cameras, LiDAR, ultrasonic, and the like. In addition, of course, to positioning devices. So it's to some degree, you can regard it as an additional sensor, but it provides more than that, because it allows the interaction between road users, and also allows a kind of a coordination and negotiation of behavior. When considering the different network communication modes that cellular V2X provides, then we are often asked which of the communication modes, the network connectivity or the direct communication mode, should be used. And our opinion is that for all latency critical local safety and traffic management applications, the direct communication mode is most suitable, because on one hand the delays are minimized due to the direct communication, and on the other hand there is no network connectivity needed for them, so they even work then in areas where no network coverage is available. There's of course another aspect where we see that certain synergy could be achieved, and this is the operation of the networks in collaboration with the road infrastructure. So consider that, the networks get denser and denser. The networks have the need, of course, the mobile networks to serve their commercial services, which are also getting more and more demanding. So there is a certain need to expand the networks in the cities and also in rural areas in order to do that. On the other hand, we see that now certain information from the road authorities could be provided into the car, and there could be kind of a synergy where the network operators collaborate with the road infrastructure in order to achieve that. And this could mean even new business models, right? So we know that the networks are always evolving. The coverage is not always the same. In certain areas, the network operators introduce new features, new services, while in other areas it's not yet the case. This is, of course, based on economic considerations. And on the other hand, we have the cities and communities which would like to deploy certain services in their area. And in our eyes, it makes sense to really think, let's say, from a holistic perspective, what is available from the network perspective, what do we need from a community, from the city perspective in terms of communication needs. Would it make sense to co-locate roadside units with small cells that provide commercial services? Let them may be maintained by certain operators potentially, to create a kind of a win-win situation, right? So the cities could offer maybe their sites for free and then ask the operators to provide then on top of their commercial service, then ITS services for free as well. So there may be different ways of thinking here. Of course, there may not be one solution that fits all. That needs to be considered dependent on the demands and desire of the different regions. And it may also not be a static thing, right? So this will evolve over time, or should actually allow a technology evolution over time, so that one does not need to stick with a certain technology for 20 years, but can expand or introduce new technologies, while of course still keeping the functionality or the early functionality that was set up at the very beginning. So there is a lot of potential in our eyes, and also a need to distinguish or separate basically the commercial needs from the needs of the society. Yeah, to get a better traffic flow, to reduce accident and the like. For all these things, I mean, there is typically not a direct beneficiary. And as long as there is no direct beneficiary, there is typically also no business case. And the idea here is to piggyback the commercial interest with the use cases that where no real business case can be seen, where only the society can benefit. And that could hopefully then lead to a faster deployment and to an easier integration and extension, or actually a wider usage of these systems. So why are we doing all that? Of course, I mentioned earlier, also the video said it. There is certain potential, and the 5G Automotive Association commissioned a study which was done by TNO in order to look at certain use cases and try to assess, okay, how much do we gain in terms of emissions, in terms of fuel savings, when we introduce these services. And you see here the list of services that were used, and one could really see that there is a benefit, and this ranges from 5 to 20% depending on the use case used. And this also depends, of course, on the penetration of these use cases in the certain regions. So the more these use cases are deployed, the higher the benefit will be. There was another study by the University of Zurich and Swisscom. They looked at how much CO2 emissions do we see in different network technologies, and they could figure out that 5G is expected to decrease the CO2 emissions by about 85% per unit of data transmitted. So this is another aspect. So on one hand, of course, the technology or the communication can help to reduce the emissions and energy consumption. But on the other hand, the technology itself also gets more efficient and allows a reduction in the CO2 emission when you compare it to the number of bytes or bits that you are transmitting. So to summarize, connected and automated driving will certainly benefit from communication, especially when 5G comes up. We think that it will create smarter ITS systems, which then hopefully lead to safer roads, a better user experience, and last but not least, a cleaner environment. Okay, that was it from my side. Thank you very much for your attention. I hope we have some time later on for questions. Thanks a lot again. Bye-bye.
Thank you very much, Ralf, for this very informative presentation. Our next speaker will be Uwe Pütschler from Nokia, Head of Global Automotive and Mobility Solutions. Uwe heads the Global Automotive and Mobility Solution activities in Nokia. In addition to his position at Nokia, Uwe is Vice Chair of the 5GA board. He joined Siemens in 1990 and held a number of positions in operations support system, research and development, before moving to the UK, where he assumed a management role in the sales organizations for 5 years. After returning from the UK and prior to his current position, he ran a business line in the global service organization and was responsible for strategic partner management. He also started Nokia's V2X activities in the Nokia Mobile Networks. Uwe holds a PhD in computer science, and the topic of the presentation of today will be challenges for the automotive use cases and solutions provided by V2N infrastructure.
Welcome to the next presentation. My name is Uwe Pütschler. I'm with Nokia, working on automotive and mobility solutions. I'm going to talk about challenges for automotive use cases and solutions provided by V2N infrastructure, so basically by mobile networks. Let's start with the main prerequisite for V2N, and that is network coverage of roads and in general transport paths. We see most of the mobile network operators working on their 4G network densification, and many have started the rollout of 5G networks already. What is interesting with respect to the transport segment is the sort of obligations which were attached to the spectrum auctions. And these applications basically force the mobile network operators to improve network coverage of roads substantially. And a good example is Germany. You see the KPIs on the slide here, which show that all the motorways and roads will be or will have to be covered with good quality networks. It's a matter of fact that not all countries have attached similar challenging obligations to the licenses. As an example, the Czech Republic has lighter obligations. You see that in Czech Republic they want to focus on the European transport corridors first and provide good coverage for those. So summarizing, we will see a lot of improvements with respect to road coverage by mobile networks. The other element is the vehicles on the roads. And we know that During the last years, the number of connected vehicles has grown substantially in all parts of the world. And now we see the first 5G vehicles on the roads. It started in China, but we have already the first European vehicle, a BMW, also here in Europe. In China, they add also short-range communications to the vehicles, and that is a trend which we will see in other regions a bit later, I expect. What's interesting with respect to the challenges of using V2N is that quite a lot of car manufacturers use V2N, so network connectivity, also for safety-related use cases. You see a few examples on the slide from Audi exchanging hazard warnings about slippery roads between their vehicles. A different use case is being worked on in the US related to school zone safety. Mercedes-Benz has made announcements about several use cases. One is pothole detection, and other car manufacturers like Volvo, Ford, BMW deploy the network for the same safety-oriented use cases as well. An interesting trend, in particular in Europe, is that most of those use cases we've just mentioned are being deployed within a fleet of a car manufacturer. And Europe has initiated an activity which is related to enabling the exchange of those warnings or hazard warnings between the different brands. The Data for Road Safety initiative has been around now for quite some time. The number of members is increasing. It's related to the 8 SRTI use cases. You see a few examples on the slide here, and progress is being made. Also, we need to admit we are not there yet. Another interesting trend is using smartphones, and smartphones connected to the network are being used in the vehicles. Very good example is in the Netherlands. One of the applications has already nearly 2 million users, and it is basically connected to intelligent traffic management with connected traffic lights, etc. And the Netherlands have very ambitious plans to grow that further. Similar deployment we see in the US, in Georgia, around Atlanta, also related to safety-oriented use cases, and the drivers can use an application. They can download the application and be connected to the intelligent traffic infrastructure. With the main objective to improve safety. But it's not just the network, it's also about deploying short-range communications along the main roads. We have examples in Italy, also in the US, and China is another region where the deployment of RSUs is foreseen. So that's all good, and we see substantial progress being made. Nevertheless, we have a few challenges. So let's talk about those challenges. First of all, there are different views about the role and the benefits of long and short-range communications. So V2N versus V2I, V2V, and potentially V2P. And those different views are not only within the OEM community, but also the road operators. They have also different views about the role, the benefits of the different two types of communications. And on top, we have the well-known challenge that we have two different short-range communication technologies, and unfortunately the community is also divided on those two technologies. So that is something which is a matter of fact. We see different trends in the regions around the world. China has gone for one short-range technology, CV2X. It looks like in the US we are also on a clear path to work with CV2X. Europe is still a bit undecided on that. But it's not just about the basic communications technologies. It's also related to how to deploy this technology and how to bring the different players of the ecosystem together. So we see many small scale technology-oriented proof of concepts and trials around the world, testing different aspects of the technology between road operators and vehicles, also between vehicles and mobile network operators. But what we can't see with those small scale proof of concepts is what is the real impact of a technical solution onto traffic safety and the efficiency KPIs road operators have, and also OEMs are guided by. So another challenge we see is the cost to digitalize older road infrastructure is substantial. And as we know, road infrastructure is being deployed for years. So there are very long renewal cycles for this technology. And more recently, another challenge has surfaced, and that is the growing number of data platforms. So this number is growing quite substantially, and we need some alignment on those data platforms. From a business point of view, the biggest challenge from our point of view is what are sustainable business and cooperation models for traffic safety and a bit more long-term automated driving related applications between the different ecosystem players which have to come together. Most of the work which has been done has been supported with additional public funding, but eventually we need to go into normal and sustainable business and cooperation models. And that is also a focus area Nokia is working on. Our mission consists of two main elements. First of all, we want to make the cellular technology, the 3GPP communications technology, as the technology of choice. And on top, we want to make data-driven business models for the deployment of safe and efficient transport systems as a basis for sustainable cooperation within the ecosystem. So these are also a reflection of the challenges we see today. If you look into a bit more details, that means, first of all, we need to establish key 5G capabilities. We are at the beginning of the 5G area, and there are many technical capabilities like edge computing, like quality of service, etc., which have not been used to the extent we would like to see, and we need to make that happen. A second important thing is establish secure and scalable edge application framework. Edge computing is an element which has quite a good potential to support automotive related applications. for several reasons. It is about latency, it's about reliability, it's also addressing the data challenge, the volumes of data we expect which need to be processed will most likely be only handled with a distributed approach. And last but not least, what I have mentioned already, enable new use cases with new business models. And these business models will be driven by data, most likely. Now, that is also something which we've been working now for quite some time. We started in 2015 with the first use cases which we tested on edge computing. And that work is going on from simple use cases to more complex use cases. For instance, in some of the European projects, we even test automated driving related use cases on edge computing. And this edge computing has been in the center of our activities. A bit later, we also started to use edge computing to link in data from the roadside. And the classical example is you have sensors along the road, whether it's cameras or other sensors. The data from those sensors is being processed on edge and then made available to the vehicles. So that's another trend which is ongoing. But whereas the first two streams have been focusing on really solving technical topics and understanding the technology, now it's really time to look into more business-related aspects. So how to make that business ecosystem work. And last year we started to implement a distributed mobility cloud. And now I'm going to talk about in more details about this distributed mobility cloud. It is a joint work with Vodafone. We started in the UK, in the West Midlands, because Transport for West Midlands is a very innovative regional road operator in the UK around Birmingham area. And the main objective of the project from the beginning was really to explore, verify, introduce and deploy business and cooperation models in the automotive transport domain. So the technical part is not the main focus. It is how to work together and how to come to sustainable business and cooperation models. And we started with two use cases. One use case is vehicle generated data, in which has the objective to really test the chain from the vehicle via the edge of the network to the road operator. And the other use case we started with is in-vehicle information, so from the road operator down to the vehicles. And it's absolutely clear these are the two use cases we started with. Now the joint team is working on adding more use cases to it. The picture on the right shows the second use case, which is about taking the information from the traffic management center, which is normally displayed at the gantries as variable speed signs or message signs, like you can see at the top, and to take the same information via the network into the vehicle. And we started with a smartphone application. And that's the existing architecture. It shows at the top the road operator system. It goes through two platforms, including the distributed edge of the Vodafone network, and via the network then to an application in the vehicle. clearly, that is the starting point. It's deployed in the live network, connected to the live system of the road operator. But going forward, we see further extensions, and that's about adding further data service providers, mobility service providers, also the link to the national access point, which will play an important role, and upcoming national data spaces. Obviously, these are elements which depend on the activities in the different countries, because it's clear the UK is only one country, and there are clear plans to take that to other countries as well. And last but not least, another element which is very important is the link to other mobile network operators, because it's a matter of fact that different vehicles and different traffic participants are connected to different mobile network operators, and that needs to be linked. What is important, it relies on network connectivity only, and it also relies on standard messages exchanged between the vehicle or the application in the vehicle and the edge platform. Just a brief overview about the first use case, so probe vehicle data or vehicle generated data. This is about really collecting CAN messages, initially from an application generated by an application in the vehicle, later on from the vehicle directly, and aggregating that information via stream processing to provide the road operator a high quality picture about the situation on the roads. That's the starting point. And it's clear, it shows the link from the vehicle to the traffic control center. And the other use case, as I explained a bit earlier, is the other way around, from the traffic control center down to the vehicle. So that's what is in place, and it is in an area in the UK. Nevertheless, there are still a few also technical challenges which the ecosystem has to work on. And the first one, which we see, is a substantial reduction of network reselection time. That is something which has been raised by the OEMs for quite some time, and the operator community now started to work on it to find an appropriate solution. I mentioned another topic, inter-MNO, inter-MAC connectivity, securing the low latency. As mentioned, different traffic participants and vehicles are connected to different mobile network operators, and if you want to use the benefits of edge computing, we need to link the edge computing environments of the different operators together. Work is ongoing. We've seen already examples at the ITS World Congress. Telefónica and Deutsche Telekom showed an example of a use case which relies on both edge environments. Another thing which is on our agenda is the fact that today the connectivity between the vehicles and the OEM clouds is something which is very important, and the OEMs rely on this connectivity. But if we want to use MAC as an important element for further use cases, we need to enable also a link from the vehicle to the MAC without going via the OEM cloud, because that would mean we lose the latency benefits again. The next topic is about predictive quality of service. That is something which will be important going forward, in particular when we talk about support of automated driving use cases, then the predictive quality of service will be a very important element to increase trust into network connectivity. And there are several other topics which will come, and the ecosystem needs to work on. Now let me summarize. The network capabilities and the use of the network has two main benefits. First of all, we have quite a lot of vehicles connected over the network already today. So we have a good penetration rate. And it's also clear, this is the second point, any vehicle which will be equipped with short-range communication will also have network connectivity. So we will always have a higher penetration rate for network connectivity. Really using this existing environment and improving environment for the benefits of the road operators and also the OEMs and the drivers. And we highlighted two main benefits for each of the parties here. Via the vehicles and the traffic participants, the road operator can get much better information about the situation on the roads, enabling a higher degree of safety and a more efficient way of managing the traffic without investing into huge number of additional sensors. So vehicles are good sensors, also for the road operators. And the benefit for the drivers or the OEMs is clearly additional real-time data have a good impact on driving comfort, increase efficiency, and also sustainability. And last but not least, the vehicles with their sensors provide a good mechanism and a good opportunity for monetizing some of the data that the vehicles can collect. So these two things go nicely together and are an important element on the way to a sustainable cooperative automated driving. And on this, I would like to finish my presentation. Thank you very much.
Thank you very much, Uwe, for this interesting presentation. Our next speaker is Dr. Andreas Wienens from Bosch, responsible for e-bike safety and holding a PhD in physics. Dr. Wienens is responsible for e-bike safety for 6 years, and he has pushed B2X e-bike in the last years. And now he's technical lead for eBike B2X. The topics of his speech: e-bike safety enhanced with connectivity.
A warm welcome to this part of the DEKRA Connected and Automated Driving webinar, in which I'm glad to share with you how we as Bosch eBike would like to contribute to safer cycling and which role connectivity will have to reach that goal. My name is Andreas Wienens. I was responsible for the safety of e-bikes for the last 6 years and now concentrate on the role of connectivity for safety, together with Christian Kosens, Peter Matt and more. Let me first start with Bosch's vision on future mobility, which is electrified, automated and connected. We as e-bikes are already 100% electrified and will get more and more connected, like for instance with our newly launched smart system, in which not only selected displays, but each bike will have Bluetooth connectivity. Profiting from the electrification and the connectivity of e-bikes, we derived some e-bike goals from the Bosch overall vision: zero stress, zero accidents, while still keeping maximum fun. As you can see, safety and connectivity are major blocks in our vision of future mobility. But how can we increase cycling safety with connectivity? This is what this talk is about. Just a hint, in the next slides I'll be using B2X and V2X. V2X refers to technologies in which any vehicle communicates with other V2X-enabled devices. If the vehicle under consideration is a bike, we use B2X, so B stands for bike. In order to understand the potentials of connectivity for safer cycling, let's have a look on the timeline of an accident and turn back time. If an accident could not be avoided, already today connectivity helps cyclists by automatically calling rescue forces using Help Connect. Help Connect is a feature in our eBike app. Right before an accident, our ABS system enables the rider to brake safely without losing control. This, of course, is not a connected product, but still it helps to ride safely. Several seconds before the crash, it would make sense to increase the visibility, but also the perception of the bike and the car. And on the long term, of course, a bicycle-friendly infrastructure is the appropriate means, together with safe routing that avoids known hotspots. But there is a gap in the timeline, and we think that with B2X technologies, we can fill this gap between ABS and long-term measures. B2X technologies can enable warnings, but also can be used for better visibility and perception, and, on the other hand side, potentially also to support automated reactions like automated emergency braking in the car. But what exactly do we need? So let's have a look in some bike accident research. First, it is important to state that most bike accidents happen in urban and suburban areas. As you can see in the shown bike accident statistics of Reutlingen for the last 5 years, there are a few hotspots, but the majority of the accidents happens quite scattered across the city, including the suburbs. So we need a solution that works almost everywhere in inhabited areas, not only at hotspots. Second, the DESTATIS statistics shows that in about 50% of the severe bike accidents, a motorized vehicle is involved. This is mainly in crossing, turning, and longitudinal scenarios. So we would need a solution that involves those motorized vehicles in order to prevent the accidents. The third analysis I'd like to show you is about the role of side obstructions. We analyzed about 2,300 bike-to-car accidents and found out that in about 24% of these cases, there was no line of sight at the moment when the accident could have been prevented by an action, like full stop braking. So for all those cases, we need something that could look around the corner, which of course B2X would be. B2X technologies look very promising. Still, I'd like to have a short look on alternatives to bike-to-X communication. Bosch provides very powerful radar and camera solutions for cars. Those on-car systems are highly welcome to protect cyclists, but they can't look around the corner. Bosch also provides cameras for traffic management infrastructure. Those cameras can detect cyclists and other vulnerable road users and can then warn the cars. Also, those systems are highly welcome, but they will not be present at each and every corner, even in the suburbs, at least not in the US and in Europe. That's why we think that B2X technologies have the potential to further increase the safety of riders and solve the situations that cannot be solved by infrastructure or car-based systems. One way to use B2X technologies to prevent accidents would be to exchange the positions, the future path, and more information, based on which a collision probability can be calculated. Depending on the technology available on the bike and in the vehicle, actions can be taken. For instance, the bike rider can be warned. We as Bosch are strongly in favor of a communication in both directions, not only to increase the visibility of the bike by sending out information, but also get information, allowing the bike rider to react and play an active role to prevent the accident. Let me illustrate the working principle of a potential collision warning system by means of an animation. First, the accident scenario is shown without communication. Both the cyclist and the car are approaching each other, but they are not aware of each other because of the building preventing line of sight. Now let us have a look at the same scenario with communication. Both the car and the cyclist are sending out information about their position, speed, type of vehicle, and future path. For cars, this message is called CAM, which stands for Cooperative Awareness Message. Vulnerable road users are supposed to use the VAM, standing for Vulnerable Road User Awareness Message. With the knowledge of both trajectories, both detect a high collision probability and hence can warn the rider and the driver. In this animation, the cyclist is warned haptically, optically, and visually. We'll come to that later. So after having received the warnings, the cyclist brakes and prevents the collision. Just for visualization purposes, the car did not show any reaction in this animation. As you know, there are several options for communication, especially indirect and direct communication. We think that with indirect communication, long-range info, increased awareness, and warnings can be realized. Direct communication, even automated reactions like AEB, could be supported. No matter what communication technology is used, I would like to emphasize that the bike is not a passive road user, but can actively contribute valuable data, similar to cars and other motorized vehicles, such as the type of the rider, if the bike is accelerating or decelerating, if the rider reacted somehow, if the bike is currently stable and under control, and last but not least, its future path in a much better way than pedestrians could do, since the degrees of freedom of a bike are much more limited compared to pedestrians. I'd like to show you some preliminary results for path prediction. Just based on inertial sensors, the future path can be predicted for 1 to 2 seconds. As you can see, the red lines, which represent the predictions, fit pretty well to the real positions, which are the red dots. Of course, the more you look into future, this cannot be done anymore only based on inertial sensors, but you will have to include further informations. Let's have a look on how cyclists can be warned. One option would be visual warnings. The second would be haptic warnings. Third, acoustic warnings. In order to find out which warnings are best suited to warn bike riders, we did a field study. During that study, the probants had to ride a prepared track and were exposed to visual, acoustic, and haptic warnings, and had to acknowledge if they perceived the warnings by pressing a button. Some parts of the track did not contain any challenging conditions, so this would be a kind of reference. As you can see, even in this environment, the optical warning was not well perceived, but only with approximately 70%. Visually challenging environments, the perception of visual warnings even dropped further, whereas acoustic and haptic warnings were still well perceived. In acoustically challenging environments, we were surprised that still the acoustic warning was quite well perceived. Last but not least, the haptic warnings were less perceived in haptically challenging conditions, like rough roads, which is not surprising. Still, this reduction might not be that relevant for our use cases, since typically, when colliding with other motorized vehicles, the road conditions shouldn't be that bad. So as a conclusion, we can see that acoustic and haptic warnings do pretty well, whereas optical warnings alone are not sufficient from a perception point of view, and additionally, the more the potential accident is getting closer, the less the rider should be forced to look on the screen, but better keep the eyes on the road. In order to learn more about the possibilities we would have when using V2X technologies, and also in order to validate the message fields in the ETSI-WAM message, we built a proof of concept. I'd like to point out that for now, this is not related to any product, but just a proof of concept. So we used the Bosch ECU and implemented a message stack including the ETSI-WAM and CAM message, connected it to the bike via CAN, hence having access to inertial and speed sensors. A collision algorithm is implemented, and the bike has acoustic, haptic, and visual warning means. In parallel, we also implemented the WAM and the CAM in one of our V2X demonstration cars, and also implemented a collision algorithm and warning on the driver's side. This way, bicycle and car can communicate with each other via direct communication or C-V2X. So this is how currently driver and rider warnings are realized with this setup. Once approaching a crossing with a potential collision situation, the bike rider is warned acoustically, haptically, and visually. For now, we implemented a pre-warning 3 seconds ahead of the crash, giving the advice to reduce the speed. Similarly, also the car driver is warned. Once a full stop brake is necessary to prevent the crash, an urgent warning is provided. This way, the accident could be prevented. So let me summarize why connectivity is a key part of achieving our vision. First, connected bikes will become digitally visible. By sending out information, the visibility of the bikes is increased. Second, connected bikes will be able to actively contribute valuable data, such as path prediction, rider reactions, or stability informations. Third, connected bikes will enable cyclists to be warned and take actions, and hence play an active role in preventing the accidents when using bidirectional communication. Fourth, already today, connected bikes can call for help using Help Connect once an accident has happened. And last but not least, Bosch has many competencies around V2X and B2X and is contributing with research, development and standardization efforts on many levels to make all this happen. So thank you very much for your attention and looking forward to safe connected cycling.
Excellent presentation, Andreas. Thank you very much. Now it's time to switch to our first panel discussion of the day.
And welcome to our first panel discussion after this first block. We're very happy to see you, Ralf, Uwe and Andreas in the chat. And if everybody has any additional questions for this afternoon for the speakers, please go to your chat and add the questions to the chat. That's no problem for us. We will then look from that. The first question we have for Ralf, and for that I switch to my colleague Thomas Jaker.
Okay, so also from my side, once again, thank you very much. And yeah, let me have a look. So first question for you, Ralf. What are important example pilot projects that have demonstrated the value that is provided by the C-V2X technology? Can you give us some insights?
Oh, well, yeah, there have been quite a lot activities in that area. As we heard already earlier, China is pretty advanced here. So I think they had this year already the third large-scale pilot in a couple of cities with a couple of thousand RSUs and a lot of actually commercial cars already deployed with cellular V2X. They are pretty much ahead, I would say. We had in the past also quite important projects in the US, for example, with the CAMP consortium. There was also a large-scale cellular V2X pilot a couple of years back. In Europe, also here, there are the first project that came up was the Convex project, which was a German government funded project. Also here, the cellular V2X was tested. Basically, the direct communication mode, which I mentioned in my talk, but also other EU-funded projects exist. So, for example, 5G Carmen, 5G Drive, 5G Mobix, all of that to some degree included that technology already.
Okay, thank you very much, Ralph. So I think we have more questions coming in, and next one will be with Vincent.
Yeah, correct. We have more questions coming in, and the next question is for Uwe. What will be the role for V2N for use cases for safety and efficiency? So use cases oriented to safety and efficiency.
Okay, thank you for the question. As I mentioned in the presentation, V2N is there. It's on the roads. Most of the new vehicles are connected via the network, and many of the also older vehicles, mid-range, high-end vehicles are connected. Hence, we have a very good basis to use the network also for safety and traffic efficiency related use cases. That's the first fact. The second fact, what is improving is network coverage. So we see even in some of the European countries that there are obligations associated with the 5G license to cover the roads. So that's another good prerequisite to really use the capabilities more and more. And we see many of the OEMs, Daimler, BMW, Volvo, Ford, using today already within their brand the capabilities to detect dangerous or hazard type of information and to distribute that information within their fleets. Unfortunately, today it's still within the fleet and not across the different fleets. But as you know, we have the Data for Road Safety initiative in Europe going on to make the next step and go across the different car manufacturers. So this is a very good basis. And I think in order to get high penetration rates quickly, that's one way to go. There is no doubt about it.
Thank you very much for that insight, Uwe. I think that's a very good insight for the audience on that. We also have a question coming in from Andreas, and for that I switch to my colleague Thomas for the question to Andreas.
Yeah, sure. Thanks, Vincent. So next question is exactly for Andreas. So that will be, how do you see that our society demands more safety features on e-bikes? So that is coming from a different perspective, but I think from a very important one. So Andreas, maybe you can share your thoughts on this question.
I think we have a technical issue with Andreas. Andreas, can you hear us?
Can you hear me?
There you are. Thank you very much, Andreas. Did you hear the question that Thomas asked you?
No, because it's my internet is lost, so I just had to dial in with my mobile phone.
Oh, okay, but it's good to have you back. Thomas, perhaps you can repeat the question to Andreas.
No worries, Andreas. That is when you are live. So the question was, how do you see that our society demands more safety features on e-bikes?
Well, we see that there are people not using bikes because of safety reasons, and that's our motivation to let's say, do our part to increase safety, like for instance with the ABS already. But still, we would like to let's say also have more willingness to pay for it, because well, as we saw for the ABS, still the willingness to pay just for safety is not that high yet.
Okay, are you still there? Good.
Yeah.
Okay, good. Okay, so I think that is an interesting topic, because I believe that, you know, connecting, I would say, mobility in this environment is not just limited to cars. So especially in the pandemic times, we had a lot of shift of momentum, especially to two-wheelers and especially e-bikes, as we could see also in Germany, for example. So I think there is a lot of interest in this, and I believe that this kind of demand will be growing in the future, especially when this technology really becomes an integral part of this kind of types of vehicles. So I think that is an important topic, and I think the demand is there, I believe. And I think it just needs something to stimulate it a bit more. And I think we are not there yet, but I think there will be a path into this, I'm pretty sure.
Whilst we still have time for the next question.
Yes.
I would say, whilst we also have Andreas, let's say, still on the line, let's say, with the connection. Let's start with a question to Andreas, and then we go back to Ralf and Uwe. Andreas, Thomas also mentioned things are coming and developing, but how do you see the regulations coming into force to enforce safety for motorized bikes using technology? What's your view on that, on the regulations?
Well, that's a difficult thing. I mean, to enforce safety with regulations, of course, that would be a means to bring that into field, and maybe it's necessary to do so. But well, I would at least really appreciate if regulations are supporting more safety, maybe not enforcing, but at least supporting, by, for instance, creating standards and also acceptance between safety standards or stuff like that, in order to really enable use cases between bikes and cars. So I would already be happy if we just had this support from the regulations point of view.
Thank you for that. Thomas, do you still have? We have some questions coming in for Ralf and for Uwe still. I propose that we do, let's say, one for the two gentlemen. Also,
yes,
let's say, looking at the time.
Yes. So, yeah, an interesting one, maybe coming to Ralf. Ralf, I think there is a question on how do you see the transition actually from C-V2X LTE now to 5G NR? I mean, this is a more complex path now into the future, where there are various roadmaps everywhere available. But I think maybe you could share a little bit of your insight on this question.
Yeah. So, yeah, interesting question. So, I mean, there's the general idea, of course, is to make use of the technology as much as possible. So, I mean, many things we can do already with LTE V2X that are currently in the so-called day one or a day 1.5 use case category, which are basically warning use cases or basic safety use cases, and this will continue. We call this kind of use case anchoring to some degree. So we say, okay, for all the technologies that, or if we have one technology that was designed or used for a certain application, then this should, of course, continue to be used over the lifetime of the cars. So it should not be that if you deploy now something, then if there's a new radio coming, that then suddenly these things are not working anymore. So as I indicated in my talk, the transition from 4G to 5G is multifold. Yeah, we have on one hand the network connectivity. Here we see, of course, based on economic considerations, the network operators deploying their network in different regions with different focus, with different releases of the technology. And then, of course, we have the car manufacturers also deploying they have a certain delay, of course, from the time they decide on something. So there's no one day where you can say you switch from LTE to 5G NR, for example. Yeah. So, and that's why there needs to be a continuous transition, and everything should work in any case. Nevertheless, there will be, of course, use cases that are where 5G is really needed, simply because of its better resource capabilities, of the lower latencies that it provides, and the bandwidth. So, of course, at the time when the networks are ready, at the time when the OEMs are ready, these can then be introduced. And as I also indicated, if we want to be independent of the networks, then of course the direct communication is key. And also here, of course, we will see a mixture of all the technologies, and it should be such that it's a device that is using 5G will also support the LTE version of it. So we have it already in smartphones today, so that there should be no issue in that regard. And we need to be careful, of course, since the lifetime of cars is much longer than smartphones, of course. So we need to make sure that the legacy technology, if you call LTE already now, will be useful even in 20 years from now.
Okay, Ralph, thanks a lot for this. I'm not sure, we have to check the timing.
We have one question coming in via, let's say just coming in last minute, and we still have, let's say, a few minutes for that. I will read it for. It's connectivity is a major part of smartness. If more devices are connected at the same time so that the interference could be happen, what is your opinion that how we can reduce that through the current trends? So I can repeat the question again. So connectivity is the major part of smartness. If more devices are connected at the same time, interference could happen. What's your opinion in how we can reduce that through the current trends? And I'm looking to the three gentlemen, who of you, as I can answer that.
Well, I can give it a start. So interference is a typical thing that in radio communication is always present if you are transmitting in a certain spectrum. So nowadays the algorithms and the mechanisms are in place to control interference and to also allow communication in congested or in loaded scenarios. Of course, at some point there's always a limit. Yeah. So, but the typical use cases that we see right now, for them, the given resources that we have in terms of spectrum are sufficient. In the future, of course, the more demanding use cases will come up. We need to see how we can manage that with a given spectrum. So potentially additional spectrum may be needed in order to serve that.
Thank you for that answer. That brings us back to let's say to the general let's say chat. Looking at the time, I think that we will close let's say this Q&A session. Yeah. Thank you, Ralph, Uwe, and Andreas for the time. Thanks very much for your contribution, and we will continue with block 2 now. We will now continue with the second block of day 1, focusing on industry and ecosystem updates. Our next speaker will be Mr. Alejandro Alonso Portero from Telefónica. Alejandro is an innovation expert at Telefónica in Spain. After several years working in the field of network functions and virtualization, since 2017 he is now focused on demonstrating how ultra-advanced 5G networks are going to be the enabler of future mobility. A hyper-connected, secure and sustainable mobility. The topic of his presentation, the mobility of the future, a hyper-connected, secure and sustainable mobility.
Hello everyone. First of all, thank you for letting Telefónica participate in this webinar, in this connected and automated driving webinar. Okay, my name is Alejandro Alonso. I'm 5G innovation expert within Telefónica Spain, and I'm here today to talk to you about the mobility of the future. This is a hyper-connected, secure and sustainable mobility. First of all, letting you know that from 4 years ago in Telefónica Spain, we are focused on demonstrating how 5G networks have a direct impact on different verticals. One of them is the mobility vertical, okay? And we have done several proof of concepts since this year in order to boost the ecosystem in these different verticals. In order to get you a deeper idea about this, we have done more than 9 proof of concepts regarding mobility and transport vertical, okay? But we have done 87 projects completed or going since 4 years ago, okay? We always try to involve our clients in our proof of concepts because we know this is the real way to obtain a really profitable value altogether when making a proof of concept while we boost the ecosystem. As I won't have time to tell you in detail about the 9 proof of concepts regarding mobility and transport that we have done these several years before, I invite you to access to our website in which you will be able to find all the use cases we have done in the several verticals in detail. Please, if you want to get deeper regarding any of the use cases you will find here that are described also in English, please feel free to contact me or whoever within the Telefónica group that will be able to give you the information, contacting internally with us that we are the responsible area of these different use cases. Okay. After this brief introduction, I am going to talk to you today about our technological pillars for future mobility. This is relying on our 5G network in order to enable this mobility of the future. After that, I will give you our mobility vision. This is our values, okay? And in order to end my presentation, I will focus on the relationship between DEKRA and Telefónica and get deeper in detail in a specific use case, and a specific pilot we are preparing for the next month, okay? Starting from the technological pillars for future mobility, you know security is critical for V2X environments. 5G networks are secure by themselves, okay? Because you know standards evolve, and while standards evolves, some security holes, a lot of them in fact are solved, and security improves radically, okay? So Telefónica's 5G network is secure by itself, okay? But we are giving more secure capabilities over our 5G network. We will get deeper in detail in a few minutes regarding this, okay? The first basic capability for 5G networks is edge computing. You for sure know about this capability is carrying the content that is being consumed to the edge of the network. This is really near the final consumer or client. This gives us really low latencies, response times, and regionalized local contents, okay? This also improves safety, security, because the contents are served for a specific and dedicated geographical area, okay? Not nationwide. The other level, technological level from 5G networks is 5G V2X. You know that 4G V2X direct communications were defined on 3GPP release 17, and today we have these direct communications called 5G sidelink, thank you to the release 17 and 16 standard, 3GPP standard, okay? 5G V2X allows the cars to communicate with really low latency between each other using a direct interface, the interface we have just mentioned, and also an indirect interface, the interface we are used to use when making a call through our network, okay? It is really important to say that direct communication can also be assisted from our network, from Telefónica's 5G network, and you know that over basic connectivity provided by 5G V2X, there are a lot of application standardizations that needs to be used in order to give a common framework for cars to communicate at the application level, okay? We, in our different proof of concepts, always bet for standardization at network level, but also at application level. This is CAM, DEM, messages, map, SPAT, and so on. The other technological lever is using 5G networks to provide a precise positioning. You know, standard positioning gives us an accuracy of 5 to 10 meters. That is not enough when using when inside the mobility scenario. So we are using techniques like RTK, real-time kinematics, corrections to be spread from onto our 5G network, okay, giving the final user, this is a car, a crane, a bike, whatever you can think, we are giving them the possibility of obtaining 5 to 10 centimeters positioning, okay? This is really important in this ecosystem, and we have done several proof of concepts using this technology over 5G networks. And the last one is network slicing. Network slicing consists in dividing 5G Telefónica network in different subnets dedicated to a specific client, to a specific purpose, or to a group of clients. V2X is critical in this future capability, network slicing, because the standardization groups, ETSI, in this case, has already defined a standard identifier for V2X in environments. This is the identifier number 4. As V2X will need a specific slice, okay, in the near future, giving the cars and all the mobility ecosystem the low latencies they need, the security and isolation they need, and the high bandwidth they will need to interchange information like high definition maps that can be processed on the edge computing in order to learn or to take decisions that will be forwarded in real time to the cars that will process that information and take any kind of action with that information. Okay. Once understood that the technological capabilities that 5G network offer us for mobility ecosystem, those capabilities are written here as basis. Let's get deeper on the vision about mobility of the future from Telefónica. From Telefónica Group, we see 3 main verticals regarding connected and automated mobility. The first one are smart cities. For example, the sensorization of traffic lights, intelligent traffic management, or smart bus stops. The best thing to understand this is to making an example with some use cases that we have already done. For example, the one you see here is one use case we carried to Mobile World Congress 2 years ago at Barcelona, in which we deployed a specific 5G network. We connected 2 cars from SEAT in this case, and also we connected bicycles, pedestrians, and a specific traffic light. Traffic light was able to detect the pedestrian and to tell the car, be careful that a pedestrian is crossing the street and your intentions are to go through that street, okay? Also, the edge computing was positioning the bicycle driver, the cyclist, with real-time high accuracy, okay? This 5 to 10 centimeter accuracy we mentioned before, calculate the trajectory of this cyclist in real time and tell the car, be careful because you are going to find a cyclist in this trajectory, okay? The other vertical is smart roads. Smart roads. This is hyper-sensorizing the roads, connecting our roads in order for them to be able to talk with the vehicles and vice versa. The best use case that exemplifies this vertical is the Therixal tunnel, which we hyper-sensorized. So the tunnel was able to communicate with the vehicles, telling them, for example, you will find a lot of snow or a slippery pavement at the exit of the tunnel, so be careful while exiting the tunnel. This warning is sent to the vehicles that go through the tunnel at the entrance, okay? Or for example, the vehicles were warned about any kind of accident, traffic jam, or whatever inside the tunnel. We also were able to expose all the information to a central dashboard using edge computing capabilities that enabled the operator, the road operator, to have in real time the status of the tunnel, okay, and taking decisions at an early stage of the problem. Tunnel is an example, and other examples are smart tolls using edge computing, also for a greener environment regarding smart roads, smart lighting, or for example, the sensorization and virtualization of black spots in order to avoid any kind of accident or prevent any kind of accident. The other vertical we see from Telefónica regarding mobility, connected mobility, is the smart industry, applying all the mobility knowledge to industries like, for example, mining, ports, or whatever. In this case, we have been collaborating with APM terminals at Barcelona. We have connected these cranes that are straddle carrier cranes. These cranes are like enhanced with this ultra precise positioning. They are located by our 5G network and edge computing with 5 to 10 centimeters accuracy, okay? So they are able to avoid accident between each other, between straddle carriers, but they are also able to report to the edge computing their exact position and history of their locations in order for the terminal operations to be aware of any kind of dangerous areas, black spots, avoiding accidents, and also knowing in real time where the cranes are located. We have also connected the staff at the terminal, this is truck drivers or pedestrians, in order to be part of the ecosystem here at the port, avoiding any kind of accidents that sometimes are fatal in these industrial environments. Now we have understood Telefónica 5G technological values and also Telefónica's vision regarding future mobility. And we all know a partnership with DEKRA is perfect in order to test the different use cases, technology, and also to certify this technology and use cases, okay? So this is why Telefónica and DEKRA are collaborating and as key partners. In fact, we have deployed 5G public coverage onto the whole external circuit at DEKRA. We have also deployed a 5G private network that is able to give DEKRA different frequencies in order for them to be able to certify foreign, let's say, devices and cars. This is certified equipment outside Spain, okay, with different frequencies in comparison with the public ones. Also, we are constantly promoting the startup ecosystem. That is why through Andalusia Open Future program, we have deployed Reto V2X there at DEKRA, in order for the startups to test their at DEKRA different use cases, technology, and boost the startup ecosystem using our Open Future OV and also WIRA. All these capabilities makes DEKRA circuit the Southern Europe's most advanced research and development laboratory for connected driving. And we all know that this is the perfect place to showcase all the aforementioned capabilities with different use cases. That is why in the following weeks we will be presenting there a use case regarding safe and efficient vehicular communications. We have created an ecosystem that will showcase 5G basic capabilities. I say basic because we have already explained that capabilities that are edge computing, low latency, and cellular V2X communications. But we will also be deploying, in fact, we have deployed a PKI, public key infrastructure from Telefónica, and capacitive technologies plus blockchain technologies. I will get deeper in this, starting by the PKI. We have deployed, as I said, a PKI integrated with European Union CPOC. Okay, this is really important. We will see why in the next slide, but you have to know that deploying this PKI gives further security to the vehicular ecosystem. You know that the 5G network by itself secures the vehicular ecosystem, but the deployment of this PKI gives the vehicular ecosystem, the mobility ecosystem, anonymization, confidentiality, integrity, non-repudiation, and authentication. Deploying this PKI and integrated with the European Union allows cars to move from one country to another, giving always being provided this security by different entities, one in each country, that collaborate all together within the European Union central point of contact in order to give this inter-country, let's say, trust level between roads, entities, companies that are registered in this point of contact, in this central point of contact that provides the European Union. Okay, we have integrated in this case in the level 0, that is the proof of concept level, to deploy this proof of concept at DEKRA. Here we will be also giving the possibility of the driver, the car driver, to bind with the vehicle. This is providing a binding service between the car driver and the vehicle. This will allow, for example, companies like car rental companies to know at each time who is driving a vehicle, in which time this person is driving the vehicle, and all this information is written in real time in a blockchain that gives the contractual, let's say, security that the information has not been modified and so on. Most of you already know the capabilities of blockchain technology. In this case, we are using Trust OS, that is the blockchain platform from Telefónica. We know that all these capabilities are really technical, and we are finding the way to show them in a friendly way. That is, we will be creating a circuit around the whole circuit of DEKRA, so in different use cases, like the one you are seeing here, sudden braking warning, slow vehicle warning. Onto those use cases, we will secure all the communications, and we will see in a dashboard the different traceability that the blockchain provides, the vehicle and driver binding, and so on. Okay, we are also giving the 5G network, our 5G network, even more intelligence, because in this circuit, at DEKRA circuit 5G network, we will be allowing the car driver, this is the final user, to subscribe to premium services. For example, a traffic light changing premium service. The driver will press a button and will subscribe to a service using Telefónica's 5G network. The idea is to show all our capabilities in a friendly way and in an understandable way, okay? To sum up, the collaboration between Telefónica and DEKRA has a long way to go. We have a lot of things, a lot of proof of concepts, a lot of technological things to demonstrate and to certify, along with a path in which 5G V2X, this is mobile communications for over 5G networks for the mobility ecosystem, settles as the industry standard for the connected mobility. I would like to say thank you to all of you for hearing us. If you have any kind of questions, please feel free to ask them or to write us after this webinar. Thank you so much for your time.
Muchas gracias, Alejandro. This was very inspiring. Our next speaker will be Mrs. Lourdes Cruz. Lourdes is currently Director of Business Development and Investment Promotion at Malaga TechPark in southern Spain. She first joined the management of the park at the very beginning of this project in 1994 as a head of European and international programs. In 2012, she returned to the Malaga TechPark management team, where she is now in charge of not only attracting new companies, but also facilitating their growth and integration in the innovation ecosystem, as well as the business development and international promotion of the park. The topic of her presentation will be positioning of the technology park in 5G and in automotive.
Thanks so much to the organizers for inviting me today to present Malaga Technology Park. My name is Lourdes Cruz. I am Business Development Director of Malaga TechPark. You probably heard of Malaga as an important tourist destination. Maybe some of you have visited Malaga, a city well known for our nice golf courses, or nice beaches, or nice food. But also we are an innovation ecosystem and an important concentration of tech companies that I am pleased to present today. Okay, some key figures of Malaga. Malaga city is the sixth largest city in Spain, with a metropolitan population of 1.2 million inhabitants and an important international community with different nationalities. The city is known or recognized as for our high quality of life at competitive prices in comparison to other Spanish destinations such as Madrid or Barcelona or other European destinations. We are very well connected, thanks mainly to Malaga International Airport, Malaga Costa del Sol Airport, with more than 20 million passengers per year. It offers direct flights to 90 destinations and most European destinations. We also have a high-speed train connecting Malaga and Madrid in 2 hours and 20 minutes, and a good network of motorways connecting Malaga, Costa del Sol, other regional cities, and of course the seaport. You can see here the Malaga area and the location of Malaga TechPark. Within a short driving distance to Malaga Airport, very close to Malaga University, Malaga City Center with a high-speed train location. And some key figures of the park. Well, the park started activity in 1992, so we are about to be 30 years old. Next year we celebrate our 30th anniversary. And it is a public-private model. Our shareholders are the local government of Malaga and the regional government of Andalusia and the University of Malaga. And you can see there we have currently 621 companies employed in the park, more than 20,000 professionals. So with these figures, we are one of the largest concentrations of tech companies in Spain. It's a big area, the park is a big area of 2 million square meters. And the investment undertaken so far amounts for 900 million euros, of which 80% come from private initiative. And the park has an important impact in the local economy, representing more than 20% of Malaga city gross domestic product. You can see here some of the companies which integrate Malaga TechPark innovation ecosystem. Some companies that you all know, such as DEKRA, of course, Accenture, Daedalus, Ericsson, Google, IBM, EY, Keysight Technologies, Pricewaterhouse, Oracle, Vodafone, Telefónica, companies which have chosen Malaga TechPark for their R&D and innovation centers, and the park is a very proactive and dynamic business community. These companies form Malaga TechPark SX, which is a business alliance, a business club, to boost Malaga TechPark leadership and to create links and synergies between our companies. Over these years, we have become a tech talent hub. As I said, 20,000 professionals of 30 nationalities. The park is an international community with more than 60 international firms located in the park. We have entrepreneurs, startups, big companies, large companies, etc., and around 10,000 people working in ICT, in digital technologies. The University of Malaga is the main source of talent for us, although we have also cooperation with other regional universities, but mainly it's Malaga University, which is a university of more than 40,000 students, and it is focused in engineering. We have 3 engineering schools offering 22 degrees in engineering and more than 6,000 students in engineering, which are our main source of talent. We are a big area, 2 million square meters. There you can see a photograph of the park's main area. We also have an important part of the park devoted for green and leisure areas, more than 900,000 square meters of green areas, and more than 400,000 built extension for our companies and different centers located in the park. We're growing these days. We are under a process to expand the park's area. And we are developing 30,000 square meters of new office space and 40,000 square meters of new manufacturing spaces. Currently constructing office space of amounting 5,000 square meters of new offices, high quality offices, and this expansion will give us the opportunity to grow and to host in the park more than 2,000 people and 2,000 companies, and duplicate the number of people working in the park in the coming years. We have all sort of work spaces for innovation, different office space, manufacturing, research, activities, test laboratories, R&D laboratories. Also incubators, open innovation spaces, co-working for entrepreneurs, etc., etc. And the landing in the park is easy. You can start with a small office of 20 square meters and grow to 10,000. And it's a very agile and flexible way of growing in the park from your initial landing. We assist you in your growth in the park. Infrastructures and services. Well, the park has a hotel, 2 kindergartens, 1 bilingual school, a sports center, a business, school, many different venues for meetings and events, restaurants all over the park, etc. And we provide services to facilitate also your integration into the local environment with many different activities for the park's companies and employees, from language courses to facilitate immersion, to networking leisure activities. We facilitate contacts with legal services, recruiting, relocation, residencies. We have agreements with residences, Malaga, and we are currently about to start the construction of a new co-living for 400 people in the park premises. Together with our main site, we also have a site at the campus, at the university campus, that we call the Green Ray, which is an open innovation place to meet university community and TechPark community. And it's also a place at the disposal of the park companies, mainly to facilitate the attraction of talent. This is the Green Ray at the campus. And together with Malaga University, we are running the observatory for the digital transformation that we call the Digital Eye. It is a joint project of Malaga TechPark and the University of Malaga to lead the digital transition of our region with different working groups on new trends and emerging technologies. We co-design with the companies in the park and Malaga University training courses designed to satisfy the need of new profiles for our companies. And we in the Digital Eye, we define new projects around digital transformation and all these technologies, so artificial intelligence, big data, IoT, 5G, connected vehicles, big analytics, etc., robotics. And we also have a clear alliance with Malaga University for research projects. Malaga University has 39 research groups working in ICT, and main areas of expertise are software, technology, telecom research, also automotives, mechatronics. We highly facilitate the cooperation between the companies in the park and the University of Malaga with joint use of tech equipment and laboratories, joint training activities for postgraduate students and PhDs, co-innovation laboratories, students' internships, and of course a specific research agreement. And currently, let me finish presenting in which areas we are currently working. We are about to launch Innova Malaga, which is a technology and innovation center formed by the actors of Malaga innovation ecosystem, Malaga TechPark, with all our companies, the University of Malaga, and also AMETIC, the Spanish Association of ICT companies, and in collaboration with Barcelona Supercomputing Center. You can see there the areas we are now focusing on. I would like to highlight that Innova Malaga is collaborative and very inclusive approach to collaborate in R&D projects, focusing in these three main areas now: microelectronics, particularly microprocessors, digital technologies, 5G, connected vehicles, cybersecurity, and artificial intelligence, and applied digital technologies to different sectors. Currently, we're working in the aerospace sector, neospace, and digital health. What we do is we have, Innova Malaga has a clear European vocation. So in this proactive and inclusive approach, we define, together with companies in the park and the University of Malaga, projects around these technologies. We are defining these projects to apply for next generation funding and all relevant European initiatives. In microprocessors, we are with these companies preparing a big project amounting 90 million euros. We opt to we hope to opt for next generation funding. Connected vehicles is an area of a specific and particular interest for us, mainly because of the companies in the park working in connected vehicles, most DEKRA or main one, and we are developing projects concerning all the wide range of technologies associated with electric cars, assisted driving, etc. And Malaga TechPark is a unique infrastructure for testing, certifying and validating autonomous and connected vehicles, thanks to the infrastructure that DEKRA has in the park, which includes both outdoor test facilities, the test ground, you can see there, with 5G network provided by Telefónica, and also indoor test laboratories and test facilities that DEKRA has in the park. And all this in an open connected vehicles ecosystem, an open environment for international companies to locate close to leading companies, and using this infrastructure that DEKRA and Telefónica provide, a state-of-the-art infrastructure to develop projects around connected vehicles. In 5G, we are equipped with a 5G open innovation platform, which is run by Ericsson in collaboration with all those companies you can see there, and it's a 5G innovation platform to develop, prototype, and different showcases for new products and services around cellular IoT, and it's a channel also for funding different innovation projects around the transition of 5G to 6G and 5G. Plus, again, we want to offer this to international companies coming to the park. In cybersecurity, let me finish with cybersecurity. We are also working, mainly because of the presence of Google in Malaga. We are working around different projects to develop a regional cybersecurity platform. We're currently preparing a project of 20 million euros. I finish with this. I stay at your disposal for any questions or any further information on the park, and look forward to welcoming you to the park soon. Thank you very much.
Muchas gracias, Lourdes, and thank you for giving the overview of the Malaga Technology Park. Our next speaker is Mr. Federico Ruiz from Mobile World Capital. Federico is an advanced engineer in telecommunications from the Technical University of Madrid. He has a long professional track record in entrepreneurship, R&D, and business development in industries such as mobile communications, semiconductors and cloud platforms. He also worked as the head of Sitsa, a company that he co-founded and where he was deputy chairman of engineering. Federico led the application of avionics in the civil and consumer electronics market. He has recently combined teaching and consulting with his mission as CEO of Finn startup Arthetica. Ruiz has also worked as an independent expert for the European Commission since the initial framework programs to Horizon 2020. And he has also collaborated on the Eureka programs with the European Space Agency. The topic of his speech of today: intelligent mobility, 5G and the future of transportation systems.
Hello, and thank you for inviting the Spain's 5G National Observatory to this event organized by DEKRA for connected and automated driving. The National Observatory in Spain is run by Mobile World Capital Barcelona. I'm an employee of Mobile World Capital Barcelona and run for the Ministry of Economics, which is the entity that in Spain rules the 5G and regulates 5G deployment in our country. How does the connected car and the transition to new forms of transport and mobility fit into the evolution of mobile senders? We might be entering a third era after two initial eras represented first by the 1G and 2G mobile senders, then the 3G and 4G mobile senders. The 1G and 2G were dominated by basic phones, cumbersome phones, hand phones, or first generation of car phones, just because they're, well, too bulky to fit into a pocket. But the generation with digital communications, mobile phones were becoming nimble enough to fit in our pocket. Then came the big transition to smartphones with the advent in 2007, 2008 of the iPhone. And these became an era of data, of people running an increasingly wide acceptance of mobile phones, of powerful computers, in fact, in our pockets. We also saw the starts of the IoT revolution. We will describe how this was connected with the smartphone revolution as well, because both IoT and iPhones share sensors and profited from economies of scale. With each generation, we saw a tenfold increase in performance, both in bandwidth, well, essentially bandwidth until now. With 5G, where we're just taking the first steps, we're entering a new era. A era where we will have not only improvements in bandwidth, but also in low latency and high reliability. And these two features are just as important as big bandwidths, as large bandwidths for the promise of connected driving, of automated driving. We're just starting with 5G. We've seen the two releases. Not everything is yet even in the marketplace. We have plenty of things to develop. This is in fact one of the reasons why 5G holds a big promise in economic and technology advances. We will have then release 15, 17, release 18, and with each release we have a pocket full of features. Many of them are related directly, indirectly with automated driving. What we don't know this time is how long it will take to make this transition. It will be an era dominated by smartphones, by IoTs, by industrial devices, by cars. We don't know. And this is what makes the observatory and the period we are entering so exciting. We're also seeing, and I try to picture that on the bottom of this presentation, increasingly connected humanity, not just the US, not just Europe, then Asia, but the whole world, with incredibly powerful phones. We're reaching peak. We're seeing the day closer, we will see peak connectivity for humanity. We will have plenty of bandwidth to connect. The question is what we will do with this connectivity in the 5G era. What we are seeing in countries like Spain, but essentially the same thing holds true for other countries in Europe, for the US, is these are lectures or signals that are on the left side that I have recorded in Madrid and Barcelona. We have speeds that can peak in 500 megabits per second. Average speeds or normal speeds are closer to tens, comfortable tens of megabits per second. But in peak situations, best case situations such as Mobile World Congress, I've been reaching speeds exceeding 1 gigabit per second in my phone. Slowly, we will see the introduction of 5G standalone networks. And this is what will trigger the low latency and high reliability networks. Slowly, we'll see high bandwidth complemented by these other two features of 5G. We will see this peak speed becoming the rule rather than the exception. As we progress upwards in spectrum, we'll have higher bandwidth, exceeding comfortable hundreds of megabits per second. And the difficulty will be to make this general to all the population and to have managed the availability and reach of the 5G signal. But I'm certain this will be achieved. So at the end of the day, at the middle of this era, we will have pocket connectivity, mobile connectivity, ubiquitous connectivity that will have speeds that are close or exceeding what we have now in Wi-Fi in our homes. And this is a completely game-changing situation. So one of the areas where we will be seeing these benefits is vehicle to vehicle, vehicle to pedestrian, vehicle to infrastructure. So other companies like Qualcomm will be more at ease in explaining you technically what this means in terms of benefits. Safety, the road to zero casualties, to zero suffering is there. We will be approaching this eventually during this decade. Energy and efficiency, sustainability. Connected cars are bound to play a big role in the transition to electric cars, to new forms of energy efficiency. So we will have benefits like brake lights that are automatically triggering when we face a difficult situation, such as a work zone, a car that has stopped ahead of us, blind curve warnings, cross traffic situations, collisions, do not pass warning. We have a plethora of standards for communication as well in car, between cars, and from cars to infrastructure. This is a huge, by the way, industrial and technology opportunity. But we have as well pending questions. And I think this is the role the observatory can play, which maybe complements the excellent work that the industry is playing in outlining the benefits of connected cars. Will it be an era and a revolution run by gadgets or by vehicles, which means customers or car manufacturers? And what will be the role of governments? If we see what has happened in 3G and 4G, it was basically us, the consumer, who ran the big spending in devices. We have devices in our phone. We replace devices in our pockets. We replace them every 2 years, 3 years. We change the battery. We update the software. We're basically running the infrastructure in the receiving side. Will it be the same for mobile cars? Will be buying devices that will be putting in cars, or will it be a feature that comes with cars when we buy them? The difference in the rhythm of introduction is striking. Remember that when in other communication markets, such as railways, it took easily a decade for new technology to enter devices. Whereas when we depend on customers on buying new phones, things are exciting us, things we pay for with our dollars or euros, it's much easier to get an initial ramp up to good penetration. The problem is, what does it take to reach complete penetration of cars? And the coexistence of a fleet of partially connected, fully connected, not connected at all customers could be difficult to manage. It could spell trouble for the future of connectivity in cars. What will be the role of governments? Will governments make the features compulsory? Regulation will play a role there, or will be running by corporate or by customer interest? Then comes the problem of data. Checked with IEEE, today's connected vehicles can create up to 25 gigabytes of data per hour. We expect with V2X that by 2030, that amount may reach 4 terabytes per hour. How much data will we process? How much will we transfer to the network, to the cloud? How much will we process in car, stored, in which format? This is an amount of data that makes it mandatory to reach a consensus of what we throw away, what we incorporate on AI algorithms, what we keep, what is key. We cannot store all this massive data. Then comes who will be responsible for harvesting all this data, and of course for running the networks along our highways and transport lanes. Who will organize it? Who will harvest it? And who will monetize and profit from this data? It's not at all decided that these will be the same entities. Remember what happened in 4G. It was not the same entities that made possible massive data gathering and who really profited and monetized this data. Then comes the key role of automated driving in AI advances. If you remember the role that DARPA played in the first stages of connected cars with the contest for cars running on the desert, that was a key driving element for advances in AI. And the same is bound to happen in AI. That will propel advances in AI in AI with reasonable consumption, in sensors, in sensor fusion algorithms. All these will happen. It's not maybe that important to know when we'll reach level 5 fully autonomous driving, but the road there will bring benefits in terms of technology that we cannot ignore. It's worth taking the road, even if the schedule and the arrival and the price at arrival is still in doubt. Something that we have been describing from the observatory is that it's not at all evident how the benefits, the economical benefits of 5G will be reached. In Europe, we tend to speak of the big hope we place in industrial applications, and mainly in low latency, in mission critical. And a perfect example of these mission critical applications is the connected car. That's the 5G industrial economy. But remember, in 4G, it was not like that. We place high hopes on IoT, on the first generation of a 1G generation of IoT, of machine-to-machine communications. By the end of the day, it was the massive broadband, the first stages of which we saw with 3G and 4G that changed the game. That was a big economical advantage. So while some players deployed IoT, struggle with IoT connectivity and struggle with the IoT problems of storing IoT, making this inventory, handle customer care. Other players play the smartphone card. And essentially the same thing could be done, or in many cases, similar things could be done with mobile phones, from mobile phones and from IoT. So what will happen in 5G? When maybe one key role that mobile phones and 5G connectivity will play will come from sensor advances. I had a look at a deep look at the first phones that we saw in 5G 1 year ago, and one exciting feature was the new sensors that we saw in the LiDAR scanners. I was expecting to see this, how technology that was developed for military use that could easily be in the range of thousands or even tens of thousands of dollars found its way into industrial, in robotics, for example, LiDAR, then came into automotive, that jump into automotive dramatically lowered the price of these sensors. And with smartphones, we are seeing the jump into consumer devices that can make this available for a few dollars. So the performance is not exactly the same, of course, but the features is there. And we saw this similar evolution in cameras, in accelerometers, in gyroscopes, in magnetometers. So one of the key issues of 5G is how we will be evolving 5G with sensors and with companion sensors for short range connectivity. Once we reach sensors in mass production for a real worldwide customer base, the sky is open basically to new forms of reality, new man-machines interface, wearables, microdrones. Is basically a new game that we are entering with 5G and connected cars. I'll give you one example connected with transport. Remember, maybe in 2002, Hurricane Sandy struck New York, and that was a big problem for New York because some of the lines that ran under the rivers were badly damaged. The structures were damaged by salt water. In 2021, it was a turn of, that's very recent, of Hurricane Ida. And extreme events are bound to become more common. And what struck me as interesting in this example is that some of the recommendations that we saw 1 decade ago related to technologies that we're seeing propelled by smartphones and the technology drive of smartphones. For example, one of the solutions that was kept for monitoring the lanes of subways was to lay LiDAR, connected LiDARs that could monitor cracks on the walls, shifts, and manage the coexistence of repairing the tunnel and running customers through these tunnels in other times. So it's a perfect example of the virtual circle that 5G and in industrial applications will bring. So thank you for giving me the opportunity of sharing with you some thoughts on that. And thank you for inviting the observatory.
Very good presentation. Thank you very much, Federico. Our next speaker will be Mrs. Daniela Petrovic from Darwin Innovation Group. Mrs. Daniela Petrovic is Transformation Delivery Director with over 20 years of experience in assisting mobile operators management teams across Europe and Asia. Daniela is a co-founder of Darwin Innovation Group, a startup based in Glasgow University and Malaga Technology Park, Andalusia, focused on implementation of telecom solutions to connected and automatic vehicles. The topic of her presentation will be satellite communication to manage the new mobility.
Hello everyone, my name is Daniela Petrovic and I'm co-founder of Darwin Innovation Group. First of all, I want to thank DEKRA for invitation to today's event. This is much appreciated. So today I'm going to talk about Darwin, our journey, our mission, our focus areas, and our partners. First of all, Darwin's mission is to work with industry partners from telecom and satellite industry and to fill the gaps that 5G terrestrial communication is not filling by augmenting terrestrial services with satellite communication services. This will enable us to have ubiquitous service anywhere on the planet. So we provide so-called connectivity for mobility service by combining 5G and satellite communication channels in one service. Darwin was created as an R&D company and gathered highly skilled professionals from both telecom and satellite industry, from academia and the insurance industry. 5G terrestrial communication channels will be rolled out mainly in urban areas, although there are solutions like shared rural networks or similar that are trying to cover bigger areas and less populated areas. However, there are still gaps left in the areas that the services are still needed, and these areas we are looking to cover with satellite services. So our solution is a solution for mobility, and we want the vehicles that are empowered with the Darwin solution to be able to send the telematics information and any type of communication via both 5G or satellite service, depending on the quality of service in the area they operate in. So I'll give you now more information about our focus areas. We are integrating mobility services in business-to-business and business-to-business to consumer models. There are four main pillars in our solution. First of all, we want to cover all land vehicles, and our solution currently focuses on connected autonomous vehicles, on manually driven vehicles like buses, vans, and cars, and on railway. On air solutions, we are looking at drones and how drones could utilize Darwin solution. When it comes to connectivity, as I previously mentioned, our solution is implementing a control logic, which is checking the quality of signal from both terrestrial and satellite channels, and based on the information received, whether the terrestrial signal is stronger or satellite signal is stronger, will switch between the two. We also have a third pillar of the solution, which is autonomy. As I mentioned, one of our main use cases is autonomous driving, and we look at V2X services. We deploy 2 test driving vehicles where we test all of our solutions. The test driving vehicles are operating in Harwell Innovation and Science Campus in the UK. We also have Darwin Innovation Lab in Glasgow in Scotland, and recently opened Darwin Innovation in Malaga. So where we want to implement all of the technologies explained here. We also have first autonomous driving shuttle operating in Harwell Science Innovation Campus in the UK. This is the first purposely built shuttle registered for as a public service, as an autonomous vehicle. And the idea is that our communication services, so the connectivity and mobility services, are implemented on autonomous vehicles, first of all on testing platforms. So this is our pre-production, and then once those are tested, we are moving the solution into production, which is autonomous shuttle operating as a public service. These are purposely built autonomous vehicles. We are also implementing solution or retrofitting the solution on the manually driven vehicles, buses, cars, vans, and the solution also works for railways. So what we are looking to do is now to create a portfolio of services that will be certified for each of these pillars. All of the solutions mentioned here are sending telematics data to AWS Cloud Platform, and where we do fleet management AI services and produce rich data for that enables, for example, our partner insurer Aviva to create new insurance models for autonomous vehicles, for example. Our connectivity roadmap is presenting on this slide. At the moment, as I mentioned in the initial slide, we tested the solution connectivity for mobility, which assumes 5G service provided by Telefónica O2, now VMO2, and Hispasat, Spanish satellite operator. We created a backend integrated infrastructure for custom provisioning and custom billing. The solution was tested in a terrestrially poorly covered area of Cornwall in England, and the results were published. We were very pleased that and presented the results in a number of conferences recently, where we showcased the switching between the two channels, between a geo-satellite channel and 5G, 4G, and 3G channels, where we showed sending telematics data and establishing Teams and Zoom calls, as well as transferring big data files, as well as video streaming without interruption or data loss. So the results are very encouraging. The results were also checked by both Telefónica and Hispasat, and we are pleased that the results were satisfactory. This allows us to move to the next stage of development, to the prototype of the solution to be together with DEKRA tested and prepared for industrial commercialization. We are also discussing with LEO satellite operators how LEO satellites could be included in the solution in the next step of our roadmap. And we want to expand our services further down on the roadmap, where we are looking to create MVNO, which is going to be specialized for this type of services. And further in the roadmap, we want to include the fiber solution to the picture, where we are including V2X services, and again offer an MVNE type solution in this case. All of this is created by help of a number of partners, which I want to mention here. First of all, European Space Agency, UK Space Agency, Telefónica, Hispasat, and our insurance partner, Aviva. Our team, as I previously mentioned, was formed of industry professionals from both telecom and satellite industry, as well as supported by University of Oxford, University of Glasgow, and soon to be signed to the Partnership University of Malaga. So I just want to conclude the presentation that Darwin is based in Harwell Science and Innovation campus in the UK, at the University of Glasgow, and in recently opened a center in Malaga in Spain. We are looking forward to hear your questions, and thank you very much again for inviting us to participate in this event.
Thank you very much, Daniela, for your presentation. This also brought us at the end of block 2, and we will continue now with the live discussion and Q&A with the speakers. Hello, I would welcome now Alejandro, Lourdes, Federico and Daniela for the Q&A session. We have some questions which came in. So we are ready for the questions. I hope you are ready for the answers to the questions as well. And let me first start with the first question for Alejandro. The first question, Alejandro, is about the infrastructure. And the question is, as we have infrastructures in both cars and streets, when do you think that this technology will be available for users?
Well, here in Telefónica, in our proof of concepts, we bet for real, real pilots, real proof of concepts with real infrastructure in real environments. This is in city environments in 90% of the use cases. So in our proof of concepts, we use real infrastructure, real connected infrastructure, okay, that allows roads to talk with the car and cars to talk with the roads. And well, it is depending right now of the public entities to deploy that connected infrastructure in a live environment, and also to the car makers' decision to go towards cellular network, and also connecting the cars using cellular network and standardized protocols and messages, okay, in order to interact with this infrastructure. So we are boosting the ecosystem, but there are some decisions yet pending for the automakers and also the public entities that are to be done here.
Okay, thank you very much for that. The next question is for Darwin, for Daniela, and Thomas, you had a question for Daniela.
Yeah, sure. So let me have a look. The question, Daniela, for you will be, can you disclose any information about potential pilots or even commercial deployments of what you are going to do in your service?
Sure, thank you for the question. Well, we already disclosed the results of our pilots. We were talking about the pilot that we just concluded in Cornwall, the area of very poor connection in the UK, where we showcased augmented service, where we used augmentation of satellite communication with terrestrial communication. And we did a number of tests which we published results of. So the results are very encouraging, and we are now implementing the solution to the autonomous vehicles. As I mentioned in presentation, we do have test vehicles in our testing areas, but we now are moving our test cases into production and allow public to experience the rides in autonomous vehicles. So our autonomous shuttle is now our production environment operating in Harwell, and we are looking forward to bring the experience to Malaga soon.
Okay, thank you very much. I think, Vincent, you have another one?
Yeah, correct. And the question I have is for Lourdes, Malaga TechPark. Lourdes, of course, you explained Malaga TechPark and, let's say, the beautiful surroundings and all the facilities. The question actually is, why do you believe that the region of Malaga is getting so popular recently from a business perspective?
Well, thanks for the question. Well, yes, it's true. As you say, we are seeing in Malaga an important increase in the arrival of tech companies to Malaga. For us, of course, is like all we have been working for so many years is happening now. The city is like having a moment. No? I would highlight, well, it's a combination of many different conditions or many different factors, but I would highlight first, talent. A talent hub with the Technology Park and Malaga University. We work very, very closely with Malaga University and other regional universities for the attraction of talent. And we have a very straightforward strategy to help our companies to attract the best local talent. And it's not only local talent, it's also international or talent from other parts of Europe, other parts of the world, because of the high quality of life of Malaga, combined with a competitive cost of living. So this helps also our companies here for the attraction of talent from other parts of the world. And we are seeing, actually, we now in the pandemic, we are seeing the exponential arrival of professionals from tech professionals from other parts of the world, like Daniela and her team from Darwin, located now in Malaga, coming to Malaga. So this is creating a wealth of talent, which helps companies located here to attract and retain the best talent they need. Secondly, I would highlight the concentration of companies working in the same technology. A concentration. We are a medium-sized innovation ecosystem, but concentrated in a particular area all together, and this helps the possibility to have collaborative projects with other companies working around the same area. It's an open innovation ecosystem, and here in Malaga we have some world leaders such as DEKRA, for example. So being here helps you the possibility to have partnerships and work in collaborative projects with tech leaders. We are seeing this very clearly, for example, in the case of connected vehicles. So this business community in technologies acting as a magnet to other companies in the same businesses. And of course, as I said, high quality of life, the Costa del Sol, the unique weather, the wonderful weather we have here, the leisure activities, history, culture, etc., and at a very competitive cost of living. And also we're well connected thanks to the international airport, Malaga International Airport, high-speed train. So this, I think, makes Malaga an attractive place to live and to work, or the combination of all these factors. Thank you.
And I think you have a kind of a winning formula there with, let's say, the talent and the businesses and let's say the quality of life. And I think both Thomas and myself couldn't agree more, as we are regular visitors to Malaga, that let's say quality of life indeed is a positive aspect there. We have also some questions coming in for Federico, Mobile WorldCom. Thomas, over to you.
Yeah, sure. I think, yeah. Just to think about what Lourdes just said, of course, the whole ecosystem over there is need also some kind of support. And there is also actually where companies that like Mobile World Capital come into the game, that are actually also supporting the ecosystem from different perspectives. So I think, Federico, maybe from your side could be some interesting point to elaborate on some insight of some projects that you are currently also supporting in order to be an incubator to help actually the ecosystem. So can you give some insights in what you are actually doing?
To witness the making of the pilots, what works, what doesn't, the weeks, the months of work of my colleagues making something happen. We basically collaborate with companies. In 2018, we had a wonderful example with Telefónica, with connected cars, detecting possible accidents on the road with bicycles, for example. That was great. Then we had last year very good examples of superposed reality. We had a test bench on the train when we had a superimposed avatar of a virtual assistant. So depending on where you faced in the train, where you put your phone, you could have access to one or the other avatar. This could be interactive. So once you start having that, it's very easy to understand why the bandwidth of 5G, the low latency matters. Because once you start interacting with avatars, then unless you have very low
latency and very high bandwidth, it's nearly impossible. So for this testbed, we had more than 1 gigabit per second bandwidth available on the train. So that was incredible to witness. For someone who's been through 3G, 4G, having this on stage happening for real was great. And then you had all the testbeds for example, connected health, ambulance connected, where you could have the whole spectrum of specialists from a hospital available on a side road. That was an excellent example of combining critical services with connected cars and connected ambulance. We had for Finnish a good variety of examples in industrial environments, automated robotics delivering parts in factories, everything related to industrial applications and mobility in applications is a booming area for pilots in Mobile World Congress.
Okay, thank you very much, Federico. I think this is very interesting, I have to say, and I believe this is great that you bring this kind of things together. Talking about connected ambulance, I think also we have some demonstration coming up, even also in Malaga in a few weeks, where we will demonstrate together with some of the stakeholders, especially this kind of use cases, which is very important also from the safety perspective. So I think then we will move on. I think we have more questions, and I think the next one will be on Vincent. Vincent, can you please proceed?
Yeah, that's correct, Thomas. The next one is for Alejandro. And the question that we received is, as network operator in various countries, how do you see the differences in potential deployments of related vehicular communication services?
Thank you for the question. We, Telefónica, as a network operator, a mobile operator in this case, have done a big investment in deploying 5G networks in all the countries. We have presence, for example, here in Spain, UK, Germany, and so on. So our vision is relying on 5G networks in order to enable vehicular communications. Why? Because 5G networks are already standardized, and as they are standardized, they promote interoperability. That is essential for vehicular communications, connected mobility. But standardized networks as 5G via 3GPP organism also have a clear roadmap of evolution and retrocompatibility that allows, in this case, new cars, future cars, to talk with previous, or let's say legacy car models, okay? And they are secure by themselves. In fact, we are even securing more our 5G network dedicated to connected mobility, as I explained in my previous presentation. So to sum up, we are we are promoting the ecosystem of connected mobility over 5G networks. This is direct or indirect communication, okay? And we are also boosting, it's not maybe on our side 100% this, but we are boosting the usage of standardized messages also on the application level. This is using CAM, DEM, SPAT, MAP messages. We are using all these messages in all our proof of concepts here at Telefónica in order to boost both the application level and the connectivity, let's say, radio level here.
Lots of developments going on and also lots of things in the pipeline, so very promising for that. Thanks, Alejandro. I know that Thomas also collected the question for Darwin, for Daniela. Thomas.
Yeah, maybe we have time for at least a last question. Looking here to my watch, I think maybe we can raise this one, and I think that is also quite important. We are talking about all of the technical possibilities that we currently have, but there might be there are some challenges. And some are coming actually from the regulatory environment. So actually the question will be for you, Daniela, what do you see as main regulatory challenges that you need to overcome when deploying this kind of innovative services from your side?
Sure, thank you for the question. Of course, we had to overcome a number of regulatory challenges to deploy the first autonomous service in the UK. Those regulatory challenges were all done within the period of 3 to 4 months. We had to talk with a number of regulators, and it's important that everyone was really supportive. So we had to go through a number of meetings and discussions and to provide a huge amount of data in order to get approvals. But that was the result was good. We got approvals and we got the registration of the vehicle. The other challenge was, of course, we needed to find an insurer who was willing to insure a product in the market which doesn't have a comparison. So we partnered with the UK insurer Aviva, who joined us as a partner in this project, where we are providing data. We created the baseline insurance product. But what we need to know to do now through this testing and basically our production and experience that we are providing to the public is to provide the data from not only from the vehicle but from the surrounding, from the users to the insurer in order to fine-tune the insurance models of the future. So we are developing an amazing technology, all of us, but we of course have to look at it as a big ecosystem of technology, and all different parts of ecosystems will have to work together.
Thank you for that, Daniela, and thank you as well, Alejandro, Lourdes, Federico, and also you, Daniela, for not only delivering your presentations, but also the availability to answer the questions that we have. That brings Thomas and me to the end of this session of today. We thank the audience for participating, and we hope to see everybody back again at the next webinar, part 2, which is on Wednesday, November 24th.
Yeah, thank you very much also from my side, and also to the speakers here today. It was very nice to see you all, and actually also from my side, thanks a lot for answering our questions today. And again, see you next time.
See you next time. Thank you.
Cheers and bye-bye.
Bye-bye.